Okay, on page 330, this section what we're going to be talking about is the properties of exponents and how they work. So the first one that I have for you, the first property, is called product of powers. And that is if you have a to the m times a to the n. Does anybody remember what you do if they're like bases with the exponents? Adele? You do not do anything with the bases, but you add the exponents. You are right. So for that particular problem, that's really just a to the m plus n. So, as an example, if I had 3 squared times 3 to the 5th, I can get by, because the 3's are the same, adding the exponents. What's 2 plus 5?
7.
Right. So then I would have to figure out what 3 to the 7th is. Rather than 3 squared and 3 to the 5th and then timesing those two numbers together. I can just do it 3 to the 7th, which on your calculators you type 3 to the 7th and see what you get. Right? Do you remember this rule?
Yeah.
Kinda? The main thing that people would get wrong, and Adele actually said it, so good job saying it, even though it was wrong, is that you would multiply the bases and then add the exponents. You were adding the exponents, right? That's correct, but nothing with the bases. Okay? That's the first power, or first property. The second one is called power to a power. And how it's worded is a to the m to the n. Does anybody remember what you do when it's a power raised to another power? Yeah, you multiply the exponents. So it's a to the m n. So in this case, if I had x squared to the 5th, according to what Dylan just told me, that would be x to the 10th. Alex, what?
Well, it doesn't matter if it's not an exponent, you just do it anyway.
What do you mean if it's not an
If
exponent?
x instead of 5. No.
I don't get what the question is.
Like if it's this.
So if it's like x squared.
No. If it's 10 squared to the 5th.
Huh?
Like if x is 10.
Oh, if it's a number?
Like, yeah.
Yeah, you can do it that way too. You could do it like if it would have been 10 squared to the 5th, you could have did 10 to the 10th, which is a number. Or you could have did 10 squared, which is 100, and then 100 to the 5th, if it's a number. But if it's letters, you just multiply the exponents and you're done. Okay? What do you think? Do you remember these? Kind of, sort of? All right, next one is power to product. And how that looks is you have a times b raised to the m. When you have two or more things happening on the inside, what happens to your exponent is it's like the distributive property where it gets put into each of the exponents, not just one. So that would be a to the m, b to the m. So as an example for that, let's say I have 5y squared to the 3rd power. Is 5 and y the same number or same thing? No. So this 3 needs to go to the 5 and to the y. So that ends up being 5 to the 3rd, y to the... Good. Now the only thing that makes this not all the way correct is the fact that I don't know what 5 to the 3rd is, which we need to figure that out. So at this time, this is where you would take a calculator and type 5 caret 3, enter, and get 125. Or 5 times 5 times 5. It's not 15. Okay? What? The caret button looks like this. On a graphing calculator, it is along the right-hand side, right above the divide sign. Even on a regular scientific calculator that some of you still have, it looks like that too. Dylan, what is up?
So if you don't multiply, like if it's a number instead of like variable or something, you have to multiply through.
Yeah.
You have to do.
So this one that you did with the product of powers.
Yeah, we should have actually figured out what 3 to the 7th was. Yeah. But I don't have a calculator. So, yeah, we should have done it out. And we will in the assignment, but not for power. Okay? So what do you guys think for power to a product? All right. The next one that we're going to need to talk about is a negative exponent. Now, last hour when we talked about negative exponent, they were kind of unsure about what to do. And so for this part, I'm not going to ask you if you remember what happens. I'm just going to show you. If you have something to a negative exponent, so if you have a to the negative m, first of all, negative exponents are not allowed. So what we do is we have to get rid of it. And what happens is that you have to move it. Now, when I call a fraction, I call a fraction not necessarily a numerator and denominator. I'll refer to it as upstairs versus downstairs. So upstairs would be numerator, downstairs would be denominator, unless you really want me to go denominator, numerator. But upstairs and downstairs. So if I put this over 1, right now, that is upstairs. In order to get rid of a negative, you have to move it to the other floor. So for instance, right now it's upstairs. In order to get rid of the negative, then it should go downstairs or into the basement. If you vacate the upstairs, meaning that there is no other letters up there, what number do you put there to hold this place?
1.
A 1. And I end up with 1 over a to the m. Now, on the other side of that, what if the negative would have been downstairs? Then you bring it upstairs. Okay? Yes, Alex?
Don't we want the negative to stay downstairs?
No.
No?
We don't want negatives at all.
Oh yeah.
Okay? So we do not want negatives at all. So that's what's going to happen when you have a negative exponent. And we'll do one like that here in a little bit. The next one. 0 exponent. Does anybody remember what anything to the 0 power equals? No. It equals 1. Anything to the 0 power is always 1. Okay, and the reason for that is because eventually if I were to show you the quotient rule, which I will show you here in just a second, if you had something divided by itself, and if you subtracted the exponents like we're going to, you would get 0. But if you had something divided by itself, isn't that going to equal 1 anyway? Right? So that's how come it equals 1. The quotient rule looks like this. If you have a to the m over a to the n, what do you do with the exponents when it's division? Subtract them. Now, here's the problem with that. I don't usually use the quotient rule the way it's intended. Okay? I don't do it that way. Because for me, if I give you something like x to the 3rd divided by x to the 7th, if I use the rule the way it was intended, I'm going to take 3 minus 7, right? So that would be x equals 3 minus 7, or x equals negative 4. But then, knowing what we just talked about on the last slide with negative exponents, can you have a negative exponent? No. So then you'd have to end up putting it back downstairs and go x to the 4th. Now, if I can go from the first one right to the answer, would you be interested in seeing how I do that? So from here, what I do is I look at, first thing is, are the bases the same? Yes, they are. Now what I do is I look at, on the top I have 3 and on the bottom I have 7. Who has more, top or bottom?
Bottom.
If the bottom has more, then the answer stays in the bottom. Does that make sense? And then I look at the difference. Then I say, all right, if this has 3 and this has 7, what's the difference between 3 and 7? 4. So what I do is, because I said that the answer stays in the bottom, I go right from here all the way to here. I bypass all that extra stuff in the middle. I keep my answer in the bottom, and I just subtract it individually to get the 4. Okay? Yes, Gunnar?
Can you have different variables?
No. Well, yes, you can. But you can't do it, you couldn't subtract them or condense them if it was an x versus a y. Then you would have to leave it just as is. But you might have a problem where it has x's and y's both. So then you would look at x's and y's separately. Okay? But for this problem, if you had an x versus a y, then you just leave it alone. Okay? Then the last one, the last rule or property is power to a quotient, and that has a over b raised to the m. Just like power to a product. Remember when I distributed it into each piece? What do you think I'm going to have to do here? Distribute it into each piece, right? So this goes down to a to the m over b to the m. So if I had something like x over 3 cubed, this would go into the top. So it would be x to the third. And this would go into the bottom. So that would be, what's 3 to the third? 9?
No.
No.
It's like 7.
3 times 3 is 9, times 3 is 27. Right? So be very careful. Don't fall into that trap. It's a trap. Right? Some of you might get that reference. No. Not Big Bang Theory.
It there too.
No.
Ugh.
Dude, it's so horrible.
I know, but that's where they.
Yeah.
No, they said it there.
Admiral.
That's not.
Okay, anyway. On page 333, sorry, inner nerd coming out. On page 333, this is where your assignment's going to be. Marin, would you be so kind as to pick any number from 3 to 35? 35?
Number 35.
Okay, this is number 35. This is what it looks like. So from here, the first thing that I want to do, I don't want to have negative exponents anymore. So what I want to do is I want to move all negative exponents so that they're gone. So which ones move? The y to the negative 3, where does it go if it's upstairs? Downstairs. Anything else? And the x to the negative 4 goes upstairs. Those are the only two pieces that are moving. Everybody else is staying put. What happens to most people is when they do this, they move everything. Is everything negative? No. Just those pieces that I circled. Only those get to move. So on the top, what stays in the first top? X squared. Good. On the bottom, I got a 3, I got a y squared that already was there, and now what comes down to join it? Y cubed. Right, good. Now on the other fraction, the y squared was already there. What do you have to play with it? X to the 4th, and I vacated the basement, so therefore I'm just going to put a 1. Okay? Now, you have options here. Couple of options. You could cancel before you multiply, or you can multiply and then cancel. It's totally up to you. All right? Me personally, there's nothing wrong with going straight across and then reducing, or reducing first. I don't really care. But if I do go straight across, if I have 2 x's here and 4 x's here, how many x's do I have total? Yeah. And I have a y squared. On the bottom, I have a 3 that didn't have any friends to multiply with. And I have how many y's, guys? 5. Now to reduce it, is there x's on the top and bottom? No. Is there y's on top and bottom? Yeah. Who has more? The bottom. By how many? By 3. So my final answer would be x to the 6th over 3 y to the 3rd. Now, do you see where I saved you some time in asking you who has more top or bottom? instead of subtracting it and then having to move it again? I saved you a little bit of time there. Some of you might be interested in doing this. Well, this cancels this out, and then going straight across. As long as you have something on the top that matches something on the bottom, or if you want to take it out right away, go ahead. What do you think? Do you remember doing these in 9th grade? Okay. Brady, pick another one. 17. Bum, bum, bum. Okay, chemistry people. Some of you are actually doing this problem in chemistry, right? Meow. Or ones like it. Now there's a couple different options for you, and hopefully you'll figure out one of them and stick with that way, but one of the options would be to do this. What is 6.3 times 8.9? How much? 50 what? 0.07. What is 5 minus 12? Is that in true scientific notation? No. What's wrong with it? I don't need parentheses, none of that. It's the 56 that's the problem, isn't it? For those of you that have done anything with scientific notation before, which I know you have, this number here needs to be a single-digit number to the left of the decimal point. Right now it's a 2-digit number. So that means the thing needs to move over one time, right? So that should be 5.607 times 10 to the... Do I add 1 to it or subtract from it? Add 1. What's negative 7 plus 1? Now, that's me doing it this way, the way that the problem intended you to do it for this particular section. However, last hour I had someone ask me, why can't we just stick that in the calculator? Hey, guess what? You can, and I don't know any different. Okay, so on the graphing calculators, for instance, when you type that in, right above the comma, for those of you with your graphing calculators, right above the comma, do you see the double E that's there that looks like capitals, but they're smaller? Okay. When I would type that problem in, I would type parentheses 6.3, and then if I hit second and then the comma button, that gives me this little E that looks like that. And then what was the first? It was a 5. And then I type 5. Me typing it like that is the same as me saying 6.3 times 10 to the 5th. That's what it's saying. If you don't want to do it that way, can you type out 6.3 times sign 10 raised to the 5th? Yes, you can. That's possible too. But you don't have to. Okay? And then you would also go over here, 8.9, second, comma, gives me the little E, and then negative 12, parenthesis, hit enter, and then it comes out with a number. Anybody type it in? Because you hit a negative or minus.
Oh, shoot, yeah, I did.
Because see how it was blinking right on there?
Yeah.
That's because that was...
Oh.
So,
Okay.
Olivia's even got 5.607 times e to the negative 6th. Some of the color screens last hour it wasn't putting in scientific notation. Then you would have to after that. Okay? Marin? I'm not sure how your calculator works yet. We'll look. Okay? So it even has the same thing we did, right? Okay, so as far as the scientific notation goes, that's how that would look. Aubrey, would you pick one more? Preferably from the top section, because we haven't done any from there yet. 13? 6 to the third times 6 to the 0 times 6 to the negative 5. Now, quick question for you guys. Are all the bases the same?
Yes.
Yeah. So if all the bases are the same, let's add the exponents. What's 3 plus 0 plus negative 5? Negative 2. So that's 6 to the negative 2. Can you have a negative exponent? No. Where does it go then? So I have 1 over 6 squared. Now to finish it out, what's 6 squared? And I'm done. Okay? What do you guys think? Not too bad? A little bit easier than some of the stuff we've been doing lately? Good. So on page 333, 3 through 33, multiples of 3. I had to do it as all of the 3's.